In this lecture, we are going to discuss about the instruction format. So before getting into the programming of 8085, we have to discuss about the major things like addressing mode, instruction format and instruction sets, because to write an opcode or to write a mnemonics, we need to be aware of these basic instructions. And in 8085, instruction set is classified into three categories considering in the terms of length of the instructions. And the instruction is nothing but a command to a microprocessor to perform a given task on a specified data. Each instruction has two parts. One is task to be performed called the operation code, that is called as opcode, and the second is the data to be operated on, that is called as operand. So the operand or the data can be specified in various ways. It may include 8-bit or 16-bit data, an internal register, a memory, or 8-bit or 16-bit address. So in some instructions, the operand is implicit. So in 8085, the length is to be measured in terms of byte rather than word, because 8085 microprocessor has 8-bit data buses. Three types of instructions are 1-byte instruction, 2-byte instruction and 3-byte instruction. So here we are going to discuss these three in depth. What is 1-byte instruction? Here the opcode and the operand of the instruction are represented in 1 byte. For example, you can see move A, B. So A, B are registers where move is an instruction, that is opcode. So it is in 1 byte itself, one line itself. And for example, in mnemonics you can see it as an add B, comma 8080H, whereas B is a register, 80H is an address, and add is an instruction, that is opcode. And second one is 2-byte instruction. In the 2-byte instruction, the first byte specifies the operation code and second byte specifies the operand. So operand is the data byte immediately following the opcode, that is MVI, 30H coded as E3EH 30H as a 2 constitutions bytes. This is an example of immediate addressing mode. And apart from that, we have 3-byte instructions, that is in 3-byte instruction the first byte specifies the opcode and following 2 bytes specifies the 16-bit address. Note that the second byte is a lower order address and third byte is a higher order address, that is the template is opcode plus data byte plus data byte. Here we have the example like LDA 2134H coded as 3AH 34H 21H. It is also example of direct addressing. So apart from this, we have features associated with different word sizes like a 4-bit processor. These processors were used in the earliest digital computers and calculators. They can process 4 bits of data at a time, which limits their capabilities in terms of processing speeds and memory capacity. And next is 8-bit processor. These processors were probably used in 1970s and 1980s and are still used in low power applications, and they can process 8 bits of data at a time, which for complex systems and better memory management. And next comes the 16-bit, and these processors were introduced in 1980s and were used in many home computers and gaming consoles. They can process 16 bits of data at a time, which allows more powerful operations and better graphic capabilities. And next one is 32-bit processor. These processors become popular in 1990s and are still widely used today. They can process 32 bits of data at a time, which allows for even more powerful operations and better multitasking capabilities. 64 bits. These processors are used in high-end computers and servers. They can process 64 bits of data at a time, which allows for even more powerful operations and better memory management. And finally, we have up to 64-bit processor used in nowadays, and basically we are using 8-bit processor and 16-bit processor in our laboratories like 8085 and 8086. So currently we are discussing about the 8085, and the last topic will be the interrupt topic. After the interrupt we will get into the programming of 8085. Thank you.